job today. Hopefully nothing too intense. My hooves are aching already just thinking about work.
Oh, it's a fine task today, Bonnie. We'll be crafting a masterpiece, an eccentric cam and shaft from a solid piece of 4140 steel. A true work of engineering art.
Sounds unnecessarily complicated. Why not just skip all the eccentric nonsense? I mean, who even notices those details?
Details, Bonnie, are the soul of precision. This eccentric cam is designed to drive motion in a mechanism. Without it, the entire system fails.
Yeah. The soul of precision. You machines and your lofty ideas. Couldn't we just use a regular round shaft or something? Who's going to care if it's not eccentric?
The engineers will care, Bonnie. Imagine a horse cart without wheels. That's what you are suggesting. Here, let me show you. This, my friend, is ingenuity. The offset cam here creates controlled motion, converting a rotary to oscillating movement. It's essential for the machine it's a part of.
Looks over-engineered? Probably more trouble than it's worth.
You know, Bonnie, the steel won't mill itself. Besides, didn't you say your hooves were aging? You'll barely need to lift a hoof with me doing most of the work.
You mean I get to stand around and look important while you do all the boring stuff? Now you're talking.
That's the spirit. But you'll still need to monitor the process, hold the material steady and keep things aligned. It's teamwork.
Oh, you're relentless. Fine. I'll do it. But if this takes longer than an hour, I'm napping mid-job.
Deal, lazy balls. But I promise, once you see this part finished, you'll understand why precision matters. Now, grab that steel round and let's make history. See? You are doing great, Bonnie. Maybe there's a hard worker hiding in there after all.
Yeah. Just don't expect me to admit it out loud.
Hello. Well, in this episode of Finno-Ugric machining, it's about making an eccentric for the retracting tool holder for lathe. There has been questions about how I make it, because it's actually a quite strange part to be made. You cannot make it in my lathe. It doesn't have the copy things you need for that. So you need to be a little bit creative how to do this. I will do it in this episode even. So, but first, let's inspect the working drawings. I have here them. So, first of all, there is this drawing about this entire thing. There will be some threading to do, M6 there, and then where we have a shaft, 10 millimeters. Oh wow, yeah, and then some stuff. But what is essential here is that there are two eccentrics, and their dimensions are not entirely in this paper. For that reason, we have another document which is actually an Excel sheet, and this one contains a lot of figures. Actually, it contains 72 cuts for each eccentric. The distance from the center, rotating center of these eccentrics. And this I use when I make the eccentrics in the milling machine. So yeah, okay. So, and of course this documentation, including the Excel, is available in my Google Drive. Just download them if you are interested in this. And yeah, well, I come back to these drawings when I'm actually doing this thing. So first we will draw, yeah. First we will turn the blank in my lathe, and that I then, when the blank is ready, I will set up the milling machine. There will be a dividing head and all sorts of stuff to help in doing this thing. So actually this can be done in a conventional milling machine without any DROs, etc. Of course you need to help yourself by setting up a dial indicator somewhere so you can see the exact distances, etc. But that's something you should already be familiar with. So let's start with the lathe and then go on from there. Now this is 25 millimeters in diameter. Well, this is mild steel. I first thought that I would make this eccentric out of 4140. But the piece I had is so large that it would be my nightmare to make it out of that. So this is it. And now let's see about some of the things like feeds here. That's the wrong direction now. That's also wrong direction. Wrong speed. That's better. Okay, then let's touch. Oh yeah, I'm facing it first. And yes, I will be silent after this, but I will supply you with all sorts of information on the screen. Okay, now it's ready. Next step, milling machine. So, this is now the setup for milling this eccentric. Well, first of all, you can see here is a dividing head. I have now set it up so that I can do 72 divisions. Well, how did I choose the correct disc with correct number of holes? Well, 72 is divisible by 3 and 9, but not 6. No, it is also. It's divisible by 3, 6 and 9. All three. But so I had actually 2 discs to choose from. One was something like 33 holes. It would be tedious. And then I had this 18 holes disc, which is actually a very good one. So 18 holes, and now if you there is 18 holes in the circle, and if this cam rotates 40 times, then it's the full circle. So it means that for every hole you get 40. No, yeah. It means that the total number of holes is 18 times 40, which is something like 1080, I believe. And when you divide that by 72, you will get 15. So every this is a 5 degrees increment. So every 5 degrees means 15 holes. Okay, so I have set up, here is the correct disc with 18 holes, and then we have the sector arms set up so that I can go on with 15 holes. Okay, so every step will be 15 holes. And at the end we should be in our starting point. And I also have marked with my pen here with blackened the hole where we start from, so I can always come back. In addition to that, I have also set this up so that there is this graduation here, degrees, so it's now agreeing with everything. So yeah, and then the workpiece itself, it's dialed in. It's accurate within 200s. I mean the concentricity, and then I have. This is something I suspected might disturb the surface of the 10mm shaft. Yes, it will actually, but I did leave some extra to there so I can wipe it out. So why I'm using slitting saw? Well, there are several reasons for this. The first one is that I can now run this machine with very low RPM. If I would have been using a 5mm end mill, it would be a horrific noise here, because you have to use quite high revolutions with that one. This one I can do with seems like 70 revolutions per minute. So it's very slow, but it still cuts as efficiently as that end mill. And then the other reason for this one is that if I would have been using a 5mm end mill, it would have been very long to reach there. Not a very good idea. Yeah, okay. So those are the reasons why I'm using slitting saw here. And it's, of course, it's 5mm wide, and it has a lot of teeth. And then I have here a dial indicator, which currently shows 0. The intention, this is just to make things easier for me. Of course, I have here the Z-axis dial, which is quite accurate, but nevertheless I would like to have a dial indicator to see at which rotation I'm on. So it gives me the general idea where I am. So that's that, and yeah. And the process is so that I first mill the first surface, then I come back like this, and then I raise the table. I have here the Excel sheet printed, so I take the next, read here, what is it? It's 100, oh yeah, and I start from 180 degrees. The reason for this is because at that point the depth of cut is 0. Later on it will deepen, but gradually. So having the first cut being something like 7 millimeters is not very good idea with this one. So it's better to take it small steps. You go deeper and deeper when you advance, and then you just come up after you have and it should be really easy task. However, this is very tedious and time consuming and whatnot. But the result should be well, it's not the exact shape of the eccentric. There is some things, but it is guaranteed that when you rotate it, it never is wider than 14 millimeters. Well, it is actually. And for this reason I had this diameter 500 smaller, because if you look into the geometry, there will be like a notch for every cut, which is about 200ths of a millimeter higher than the actual cut. This 0.5 millimeters from diameter, then it's okay. So now, let's start with this thing, and I adjust some cameras, etc., so that it's better for you to see. And yeah, this is a tedious thing. I won't speak anything because this needs all my concentration. If I try to explain what I do, I will do something, but it might not be the thing I really would like to do. So, let's start with this one. So yeah, the first eccentric is ready. 72 cuts, and at first I made a very stupid mistake. I miscalculated the number of holes. Actually it should be 10, not 15. So 3 first cuts, a little bit strange, but it straightened out. Nothing too bad happened. I catched it in time. Well, it's the thing that you have the degrees and everything, so I could check it. Yeah, so that it advances 5 degrees every time. And now the next step will be to make the other eccentric. And I will do that off the camera. I'm pretty sure you got the idea already. Hopefully there will be no mishaps with this one, because there is very thin web. It's not very steady, because I couldn't use the tailstock here. So yeah, okay, but yeah. So after this, the eccentric is ready this time. There is one feature that should be done, but I will do that later. So yeah, so let's see now. I will make a fast forward for that one for you. Maybe some music. Let's see what I can find. Okay? Now something completely different. This is a part from the tailstock. Well, the design is a little bit stupid. You have a knob which is very large. It's otherwise low profile, but this large knob actually makes it so that it's about 10 millimeters higher at the end, and that that makes it unusable in this case. But if I turn it down, so then maybe, yeah. So next step, turn that one down. Okay, that's now the part. Well, it's a lot smaller than you could imagine. Well, it succeeded quite well. I think it has a great resemblance with the picture, especially those eccentric pictures. And now, well, that feature is something I will do in the near future. It will be for the lever. There will be a lever in this one. And yeah, okay. So I learned something about this, and if you intend to do this, so it's a good idea to leave here some extra stock at this end here, this end, so that you can hold it in lathe and etc. if you need to do something afterwards. I needed to face this afterwards. Of course, you can hold it on this shaft, but well, it leaves marks to that. Not a very good thing, yeah. But the method of making this eccentric by slitting saw was actually very good. Well, the surface finish is, how would I say it? It's somewhat, well, it looks like scratched, but it is because of the slitting, so it was a little bit old and so on. So now that's the first part done. Well, next will be the holder, the one that goes into the lathe and holds the entire thing. And this one, of course, attaches there. There is a bronze bushing which holds this in that one. But I will do that in the next episode. Till then, bye!